Hello everyone, we are solving problem number 1143, longest common subsequence. So this is a very standard problem and one of the most important problem in the dynamic programming. So let's check it out. So in this problem we are given two strings. I will take them here for explaining problem. So those are the given strings and we need to find longest common subsequence. So that means the uh, common characters between those two strings, but we should maintain the order. So I will explain what I'm trying to say. So we will just as you can see, a is common and it is coming first, so let's add a to our answer. Okay, now if we check further, b is not matching anything, but we can see c is matching c again, so we will add c here, and in the end we do also have e. So this is our longest common subsequence, and here we can see we are maintaining the order. Here a, c and e are coming in order while this is the complete string. Okay, so other possible common subsequences are, let's say, a, c, e, ae and ac, but we need to return longest one, so we are returning ace. So for this problem we are going to use the recursive approach and we are gonna make two calls. So what we will do is we will check if current character of first string is equal to current character of, this is not the code, this is just try run algorithm for explaining this problem. So in this case we will increase our answer by 1, as we are getting one new same character which is matching. So, and if the character is not matching, then we are going to have two case. So case 1, so let's talk about after a is, here we can see a is matching, so we will move those two pointers by one simultaneously. But in next case we here have b and here we have c, so here b and c are not equal, so in this case we will shift only one string at a time. So in this case we will check for c, d, e and ce. So in this case we are moving pointer of first string by one and keeping pointer of second string on the current position itself, while in second case, case 2, in second case we will keep our current pointer of first string as it is, while move the pointer of second string. So in this case it will be bc, de, and the another string is gonna move forward by one, so we are going to just get e here. So we are going to solve for this, and this function is gonna get called recursively, and here answer is gonna get by maximum of these two, case 1 and case 2, as we are gonna check by doing which by using which case we are getting maximum answer or longest common subsequence. So we are choosing that for final answer. So this is gonna be our algorithm. So let's write the code. So for that I will make one recursive function. I went in, let's say, solve lcs. Okay, so we need to have those strings as inputs. So let's say string s and string t. Okay, we also need two pointers as I mentioned, so let's name them m and n, which are going to move from 0 to till end of the string. Okay, so we need to check our first condition. If s dot char at m is equal to t dot char at n. So if the characters of current indexes are matching, so in this case we are going to make so let's make one answer variable here. So int answer is equal to 0. Okay, so in this case answer is going to be 1 plus we are going to make recursive call and increase the both the pointers by 1. So t, in this case m plus 1 and n plus 1 also. Okay, but if those characters are not matching, so in this case we need to find maximum of mat.max. So solve LCS of s and t are gonna be common. Then we are going to increase pointer of one string at a time n. Okay, and another one is solve LCS. I will take it to the next line. Okay, s t m is gonna be as it is, and we will increase n in this case. Okay, so we will just return answer, and we need to make one base condition. If m is equal to s dot length, or n is equal to t dot length, then we need to return 0, as our string will be overflowed. So we will just call this function in the main longest common subsequence function. So we will just say solve LCS t1 t2 then 0 and 0. Okay, so let's try to run this code. This is a simple return 0. Okay, this is a simple brute force recursion, so we are going to get TLE. So after that we will memoize it. Yeah, as expected we are getting TLE. So let's optimize this problem using dynamic programming. I will make one integer dp. So let's initialize it here, new integer. So let's say t1 dot length and t2 dot length. Okay, so before returning we will just store that value so that we can use it further when we are gonna need it. And we will just make one check here. If dp of m n is not equal to null, so we'll just return that value as we have already calculated it. Okay, so let's try to run this code now. Okay, it's running. Let's try to submit it. Yeah, and we are getting the answer.